Okay, this video will demonstrate how to go about completing the analyses and write-ups for practice A&R number 3. So I'm going to go ahead and collapse all of these, and one of the easiest ways to get there is it's in our current folder, our week 13 folder, or module, excuse me, and you'll see it as practice A&R 3, hit high intensity whatever that interval training study optional. So you go ahead and click that. This is an optional assignment. It's simply for practice. So there will be no points assigned to this. It's just for you to practice with and see what the actual A&R 3 is going to be like and work through similar scenarios so that you get that additional practice with the content that we've been covering, which is t-tests generally, and confidence intervals and z-tests. So here is our research scenario. For some time, scientists have been intrigued by the idea that breaking up exercise into repeated short sessions might be as beneficial as longer workouts. The objective of this study was to compare the effects of short, high-intensity intermittent workouts, those HII, 7 minutes, against continuous moderate exercise, or one 30-minute exercise session. So we're comparing a short, high-intensity 7-minute workout versus 30-minute regular workout of moderate exercise. A team of sports psychologists randomly assigned 100 participants to either the 7-minute high-intensity workout, and we can see some examples of what that workout looked like, or 30 minutes of a moderate exercise program. Participants came into the laboratory to perform 18 training sessions over a 6-week period with approximately 3 times a week. Participants' weights were tracked from before they started the exercise program to immediately after, and again 1 month after the exercise program stopped. So 3 time points they collected weight. Now the variables included in the data file are described below, and you can grab the data by clicking this link. So we can see here's our data, and if you want to open it in JASP, I'll demonstrate that in a moment. So here are our variables. We have gender. 1 is assigned for male, 2 for female. Age in years, number of years. Exercise condition. So whether they were in the 7-minute workout condition, the high intensity workouts, or the 30-minute moderate workouts, remember they were randomly assigned to be in one of these. Their weight before starting the workout program, weight immediately after finishing the workout program, and their weight 1 month after finishing the workout program. Now we have 2 variables that have already been calculated based on their weights. So weight loss immediate, this is the weight after minus the weight before. So this gives us a measure of how much weight they lost from immediately after the exercise program from before. So that's their weight loss immediate. And we should note for both of these weight loss variables, a negative number means that the number of pounds that they lost. So a negative number is a good thing in this case if they're trying to lose weight, while a positive number indicates that the number of pounds that they gained. So both of these weight loss, remember negative means they lost weight and positive means they gained weight. Now with weight loss long term, this is their weight 1 month after minus their weight before. So looking from their before they even started the program to 1 month after they completed the program. And this gives us a measure of how much weight they kept off 1 month after the exercise program ended. And this variable is notice only called long-term because it's relatively longer than the immediate weight loss measure. So now since not everyone can access JASP, an output file has been generated containing the results of all of the relevant tests. And it's here. Now, please note that you will have to choose which analyses and outputs are relevant to the research questions asked, as not all of the outputs are necessary or there may be duplicate information, right? So I completed a bunch of tests, some of which you may not need. So it'll be up to you to determine, based on the questions asked, which test is relevant. So you can open that directly here, and you'll see this includes some descriptive statistics. We see the weight before. We see a one sample t-test, a paired samples t-test, and an independent samples t-test. Another independent samples t-test, and that looks like it. Okay, so it'll be up to us to figure out what all this is saying in terms of the research questions asked. Now, if you want to work through the questions using JASP, then you're going to come to this link where the data is housed in the Google file, come up to File, Download, and you want to download it as a comma-separated values file, .csv. Now, don't click on it directly. I'm going to say Show in Folder so I can see it. Now, what I want to do, I don't want this. You can see it automatically defaulted to wanting to open this in using Excel, which is what I have on my computer for spreadsheets. I actually want to open it using JASP. So you can open with, but it might not show up. So rather than doing that, what I do is I start by opening up JASP. And then I say open a data file. I want to search in my computer. And I know that it downloaded to my downloads folder, so I'm going to go straight there. And here it is, the Practice A&R 3. So now here it is in JASP, and I can do my analyses with it. So I don't even need the Google Sheets anymore. And we can then compare and see where these analyses are coming from as we complete this. So I'm ready to go ahead and begin and see what those research objectives are that I'm trying to meet. Now, the first question, and no, all of these are 0 points because, again, this is a practice assignment and optional. Won't count towards your grade. There are 5 questions on this one, but there are only, I believe, 4 on the actual A&R. So this is a little bit longer for extra practice. Okay, so please use the provided JASP output. All right, so I'm going to go ahead and just split my screen here so I can look at both at the same time. And we'll refer back to JASP to demonstrate how we get these. Let me go ahead and make this a little bigger so we can see that easier. Okay. Now, okay, so please use the provided JASP output to answer this research question in APA style. This is where that practice is going to really come in with using that APA style guide that was provided and the examples in the classwork. So based on this sample, estimate the average starting weight of the population. So this is going to require some contemplation about what do we use, which tests or which statistical tool that we've talked about do we use when we want to estimate for some parameter. In this case, we want to estimate the mean weight, right, that pre-weight of the population. So thinking about that, what tool do we use when we want to estimate for a parameter in a population, an unknown parameter in a population? In this case, we're going to want to report, right? We could start by saying, well, if we look at just our sample, based on this sample, the average starting weight, so here's where we get that weight before. Oops, where did that disappear to? There you are. So how I got this, we go to descriptives, and we want to look at average starting weight, so weight before. And this gives us a similar output, but you'll notice something here. Really, when we want to estimate for an unknown population value, a population parameter, we could estimate just using this mean, 179.4. However, that we're not likely to be right if we're that specific. So we want to widen the range of possibilities, the range of likely possibilities that we think that population parameter probably is from within this range. So when we're doing that, we want to look at, under statistics, we want to come down here under inference and select for confidence interval for mean. And this will now give us an output similar to what we have here, right? Same thing. And let me go ahead and close this analysis. We're done with that one. So based on this sample, the population, the average starting, or the average weight of the population is, oh, I know an even better way to say this. Let's try, I'm going to use the we because we're doing this together. We are 95% confident the average weight of the population is between our low, I don't know why this thing keeps doing this to me. There you are. It's because I zoomed too much, I guess. So is between 172.6 and the upper, so the lower to the upper, 186.2, and we're talking in pounds here. So we're 95% confident the average weight of the population is between 172.6 and 186.2 pounds. And in our particular sample, we have an average of 179. That's it for that one. Now, was there a significant, each of these will specify, so use the provided JASP output and answer in APA style. So was there a significant change in participants' weights from before starting the workout program to after finishing the program, regardless of exercise program? So regardless of exercise program, we're just looking at everybody. When we look at everybody, is there a significant change in their weight from before they started the program to after? So if we think about this, where are you hiding? There you are. So if we think about this, we want to compare their weight before to their weight after and see, is there a significant change between these two things? Now we are comparing two means before and after, and each of these values is coming from the same participant, right? The same person's before with the same person's after. So that tells me these two numbers are paired together because they come from the same participant. So that tells me if I'm comparing two things that are paired together, probably the easiest way to do that is by doing a paired samples t-test. So what I can do is look at how much they weighed after and compare it to how much they weighed before. And this will tell me if there's a significant change or a significant difference in their weights before and after. Now, I just want to quickly demonstrate something here. If I switch the order these go in and I put before in first and after in second, we ultimately get the same t value, the same degrees of freedom value, and the same p value. The only thing that changes is this t turns negative because it's just, are we subtracting this from this or are we subtracting this from this? One is always, one will be bigger than the other probably. And so just which direction this negative comes in it just depends which one we put in first. So what's actually going to help us, okay, if there's a significant difference here, well, which one's more, before or after? We can't see that from this. So we'll go ahead and under additional statistics, we need to look at those descriptive statistics. So once we click that, now we can see, oh, the weight before was on average 179. The weight after on average was 169. So on average, and similar standard deviations. So it looks like on average, everybody lost about 10 pounds. That's cool. We can even look at it using our descriptive plot. Now keep in mind, this doesn't start at 0, so it looks like, but yeah, look, there's a significant weight loss from before to after. We can see it's significant because of our p-value. Our degrees of freedom is 100 people minus 1. Here's our t-value we need. So this really tells us, if we're looking at these two curves, there are 21.5 standard errors that fit between those means. That's a lot. There's a big difference between those means. So there's a significant difference from before to after. With after, they lost a significant amount of weight, about 10 pounds. We can also look at the confidence interval. So when we add that, this changes this top table. We now can see the mean difference, that's if you subtract these two, is 10.194. So there was a significant mean difference of 10 pounds, a little over 10 pounds. And here's our confidence interval. We're 95% confident that in the total population, if they followed one of these two weight loss programs, they would lose between 9 and 11 pounds. It's pretty good. So that's what we can conclude from this analysis, this paired samples analysis. So how do we write this up? And I also, before we do that, so let me close this one. I want to demonstrate that you can also do this same, you can answer this question a different way. So thinking about it, was there a significant change in participants' weight from before to after? We're asking, is there a significant weight loss, right? Right here, weight loss immediate. Is there a significant immediate weight loss for everybody? So if there's not a significant weight loss, then we would expect that number to be 0 or above. So we can also run a one sample t-test on the immediate weight loss variable. And you'll notice that if we do this analysis, we're going to get the exact same values because it's doing the same thing. It's just doing the subtraction ahead of time. Right? If we do descriptives, we'll see the mean weight loss is 10.194. That's what we saw above. Let's see. Oh. And no, is that the right one? Yep. You see how before we had it was between 9.25 and 11.13. Guess we put it the other way in. See, same numbers. So it doesn't matter if you run it as the paired samples between before and after, or if you run a one sample against 0 weight loss on the immediate weight loss one. You'll get the same conclusion. So let's go ahead and write up the paired samples example. And you'll see if you go through this output, here's the one sample t-test. So if you want to practice writing up the one sample, it's here. And here is the paired samples t-test. And I also added, you can get this chart by selecting for bar plots. Oh, so sorry, this was the wrong. Well, that's how I got it for the one sample. And it's the same thing under paired samples, under bar plots. There you go. So let's write this up. You know, since we're doing this as part of a bigger analysis, let's go ahead and jump. We'll skip that first sentence that we usually include, like the purpose of this study is to do, or our goal is to do this, and focus really specifically on this test. So we can start by saying results of a paired samples t-test. And actually, I've looked at the recent APA guidelines, and I believe the most recent guidelines say it should be formatted like this, with T in italics and no hyphen. Looks weird to me, but I'm going to practice it so it'll get less weird. So results of a paired samples t-test showed participants lost a significant amount of weight from before starting the workout program. And I'm going to end up putting in here what my mean and standard deviation are, but I want to finish my thought. So, showed participants lost a significant amount of weight from before starting the workout program to after finishing the program. And then I'm going to put my mean standard deviation there. And then I'll put my T and all of that stuff here. Okay, so it showed they lost a significant amount of weight from before. So here let's put the mean of the before, 179.4. We'll just do 1 here. And our standard deviation, the average spread around that mean was 34.72. To after finishing the program, and now here again I'm going to do capital italics M for mean, space equals space. Now the after weight was 169.2. And the standard deviation, capital SD in italics, then space equals space, and the standard deviation that goes with the after, 35.77, I'm going to round. No spaces with the parentheses here. Then comma, space, this T I know I need to put in italics. Any of those statistical abbreviations, the M, S, D, T, P, all those go in italics. Now inside the parentheses is where we're going to come up here now, my degrees of freedom goes. Degrees of freedom is telling me which of all those infinite T curves that we have, the family of T curves, which one am I specifically referring to based on how many people are in my sample. So with 100 people, I'm looking at 99 degrees of freedom. Then space equals, let me take these out. Now after T with 99 degrees of freedom equals the T value, 21.55. I'm going to round again. Comma, space, then in italics, my P, space, and then if I have a value right here, point something, 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 other than this less than, I would put equals that value, 0.234. When I have this special case where it says less than 0.001, this is telling me the probability is so small it's less than 0.01% chance that we would get that if the null is true. Now, actually, let's do another comma, and I'm going to add in the 95% confidence interval for mean difference equals, and I have to double check. I'm pretty sure that this one is in italics, but I'm not sure about this. I don't think so. And then I'm going to do equals bracket, like the square bracket. Then I put in my 95%, or my lower here, 9.255, or 2526 if you want to round, comma, space, and then my upper confidence interval limit. And then end your bracket and put a period. So here is my full write-up addressing this question. Was there a significant change in their weights before and after? Results of a paired samples t-test showed participants lost a significant amount of weight from before starting the workout program, with a mean of 179.4, standard deviation of 34.7, to after finishing the program, when they had a mean weight of 169.2 and standard deviation of 35.77. The T with 99 degrees of freedom was equal to 21.55, that's very high, indicating a probability of less than 0.001 that we would see this result by chance. We're 95% confident that participants completing these workout programs would lose between 9.26 and 11.13 pounds. Okay, so on to our third problem in our practice. So let's see. Again, using the output, a research question, APA style. Does the type of exercise program, so the high intensity versus the regular, make a difference on immediate weight loss? So this is clearly telling me my two variables. It's asking about whether this independent variable exercise program, whether they did the high intensity versus the regular, make a difference on this dependent variable, independent weight loss. Sorry, immediate weight loss. So, little Freudian slip there. This is going to be an independent samples t-test that we do here. So we can see the results are here, independent samples t-test. And here we're looking at, again, immediate weight loss between our two groups, the 7-minute group and the 30-minute group. Remember, they were randomly assigned, so half were in each. We can see the average weight loss for each of the two groups, the standard deviation for each of the two groups. Now you know what this means. SE, that's the standard error. So that's the standard deviation of the SDOM, right? So if you were to do a problem by hand, it's at least saving a step there. And we can see what this looks like graphically as well. So to get this output in JASP, we are going to navigate to our t-test window, independent samples t-test classical. And the reason why this is an independent samples is because, remember, half of them were in one and half in the other. They were randomly assigned. So it's two completely separate groups of people. There's nothing that links a person in one group with a person in the other group. So the scores are not linked or matched in any way. So it's independent. We want to look at immediate weight loss as our dependent variable, and our independent variable or our grouping variable is exercise condition, which one of those two groups they're in. Again, we want to select for some additional information. We want to get our 95% confidence interval. Our effect size, Cohen's d, is always handy to have. It's not in this one, but it is handy to have that. Descriptives, so we can see this information, mean, standard deviation for each of our groups. And if you want to see the bar plot, for example, you would select for bar plot. Now we can see our result here and that this information is the same. So this is where this information has come from. So if we are to look at this, we can see the two means. They don't look that different. I can see the mean difference is less than a pound, and my p-value shows that it is not significant. There's not a significant difference between them, which makes sense because it's like hardly any weight loss difference between them. So to write that up, we would say that an independent samples t-test showed that, you can mix up your language, but we want to name the test, and we want to indicate that showed no significant difference. Right? There's no significant difference here because our p-value is above 0.05. So no significant difference in immediate weight loss between weight loss between the HII group, and then again I'm going to want to put my mean standard deviation there, and the, what did we call the other one? Moderate group or 30-minute group. However you want to indicate it. Then we'll put a comma, and that's when we're going to put our T with degrees of freedom and so on. So my sentence is complete. It's time for me to fill in the details. In here, I want to put the mean and standard deviation of the group I just mentioned. So we're going to put the mean and standard deviation from here. Again, mean is in italics, capital M, and then take off your italics, equals, and space on either side, and it's negative 10.51. My standard deviation equals 4.68. Now, and you can even save some time if you want, but be careful with this. Make sure that you are updating everything. You can copy and paste, and that'll help you with the formatting. So my mean is 9.88, 4.81, and these are coming from this second row here. And now we're going to fill in our T information. So we're good with this one. Up here, the actual results of our t-test, we put in here to specify which curve we're looking at. So degrees of freedom 98, that goes in here. Then close it, equal space, equals. Now our t-value, yeah, that worked. Then comma, in italics, p, And here we'll see the case where we can say equals. P equals this number, 0.508. And then we can also include 95% CI for mean difference equals square bracket, and then I'm going to put my lower and comma, space, then my upper. Close bracket, period. Now you'll notice that if I look at this interval for my confidence interval, it goes from a negative number to a positive number. That means that 0 is included in this interval, which means that 0 very well could be the true population mean difference between these groups. It could be that there's truly just 0 difference between these groups. Right here we see almost 0, but it could very well easily be 0. Now, our next one, does the type of exercise program make a difference on long-term weight loss? So this feels like it's asking the same things before. So look at the difference here. Does the type of exercise program, that's the same, make a difference on, okay, so we were talking immediate weight loss before, now we're talking long-term weight loss. So we're going to run essentially the same analysis, but instead of looking at that immediate one in the dependent box, we're going to look at long-term. And then the cool thing about this is we can basically copy and paste this since we're doing the same analysis. We just need to make sure that we update everything, right? Instead of immediate, it's going to be long-term. And then we want to make sure that we clear out this information here, the actual numbers, because these are likely to be different. But at least we can use the same formatting. This 98 should be the same. But we'll just show. We'll let this cleared out. Okay. So let's go ahead and run it. So I'm going to do another independent samples t-test. And here, let me show you a trick in JASP. So let me delete that one. What I'm going to do is go back to the one that I just did. And if you click on this little green button, it will duplicate, it'll make a copy. So that was my first one. Here's my second one. And I can even rename them. Like, how do I do that? It's one of these. Edit the title. Right? If you want to keep things neat, you can even say like long-term weight loss. And that way we'll know this one's a different one. So with that in mind, we no longer want to look at immediate weight loss. So we'll take that out and take long-term and put it in. And everything else that we've got should be already set up how we want. Ooh, look at this difference. Wow. That's very different than what we saw with the immediate weight loss. With the immediate weight loss, we saw that both groups lost a good amount of weight. The high intensity lost a little bit more, but it wasn't a significant difference. But when you look at the long term after a month, the high intensity group still has maintained their weight loss. Look at this, 10.36 versus before 10.5. So they've essentially maintained their weight loss over that additional month. Whereas look what happened to the moderate group. They gained their weight back. Their mean is 0. So this really tells a story for these sports psychologists, right? So let's go ahead and write up and you'll see we again have this same information presented in the PDF for you. So if you can't access JASP, it's okay, you got it here. Okay, so an independent samples t-test showed So here we got to change this. It was a significant difference. So we could say a significant difference, but that's not really going to tell us the whole story, right? So maybe what we want to say instead is that showed significantly higher or significantly more, significantly higher. Yeah. Long-term weight loss in the high intensity group than in the 30-minute group. An independent, so your sentence without all the stuff in parentheses and statistical gobbledygook, it should read as a normal sentence, as a full normal sentence. So an independent samples t-test showed significantly higher long-term weight loss in the high intensity group than in the 30-minute group. Makes sense, right? So we can leave it there. You can also phrase this other ways, like the results of an independent samples t-test indicated the high intensity group had significantly higher long-term weight loss than the 30-minute group, right? You can phrase it different ways, but the sentence should make sense when you just say the words themselves. Okay? So let's fill in our details. So the high intensity group, again, that's going to come from this top row here. So my mean is negative. Yeah, they did a great job maintaining that weight loss. I'm going to speed things up here by using my copy and paste. So that's the group. And then the 30-minute group, we need their mean and SD. So here's my 30-minute group, mean and standard deviation. Now my T of how many degrees of freedom? Let's come up here. 98 degrees. Haha, it takes me back to the early 2000s, late 90s. I don't know. T, I'm going to copy that and put that in here. P equals up. We're going to have to change that because check it out. P is actually less than 0.001. And this note, let's take that off. This note is essentially telling us that we want to be cautious interpreting this, given that we see such big variation in, or we see a big difference in how much variation we see between our two groups. We see that the high intensity group, they had a lot of variation, right? But the the moderate group, they had less variation. And so this can be an issue when we're interpreting these statistics. And so this is saying, hey, you might want to double check this because it looks like you have a violation of that assumption that you have the same variance in both of your groups. Now, generally what you want to do in those situations is run what we call a non-parametric equivalent test and look at those conclusions and draw your conclusions with that information. I've already done that and we get the same conclusion regardless of which test we run. So we're just going to continue focusing on reporting this one. So our 95% confidence interval for the mean difference, we're going to put, remember we have one that goes in right there. That's going to be our lower and our upper. And we can see this time 0 is not in that interval, meaning that our model, we're estimating that we would see between almost 9 and 12 pounds difference in that long-term weight loss between those groups. So we would expect to see a significant amount of difference where the short, high intensity workout group has lost or has significantly more weight loss in the long term than the standard 30-minute moderate group. Okay, now finally, the sports psychologists wanted a better idea of what people in this population weigh before starting a fitness regimen. They found an article that says that the 95% confidence interval for the average weight of adults in the US is between 172.5 pounds and 186.3 pounds. Please interpret this so they better understand what it means. APA style is not necessary, but include any relevant values to help you explain. Okay, so they want to know, what does this mean? When you say there's a confidence interval for something and you give me two numbers, what does that mean? Well, that means that we're 95% confident that the true population mean weight is between 172.5 pounds and 186.3 pounds. That's pretty much it, right? It means that we're not 100%, we don't know for sure what the mean weight is, but we're pretty sure it's between this and this. And if we wanted, we can even look back at what we had on our first page here and see how does that compare with that confidence interval we had for our data. So ours was, look at that, 172.6 to 186.2, very close. So yeah, we're 95% confident that it's between those. So it could be as low as this, could be as high as this, but probably not higher than that and probably not lower than that. Chances are less than 5% that would be the case. And that is it. And as you see, it's worth 0 points. And you can see all your answers here. And if I am not going to have time to grade all of these, grade all these. But what I'll do is I'll save these answers and I'll submit this as the key so you can compare your answers against these ones. Okay. Best of luck.